Ja, da var det Hustad. Oi. Åh.
Ja, promp er jo helt naturlig. Og noen er det jo litt lukt på. Som jeg kanskje kjenner litt nødt nå. Ja.
FINN.no.
Hello and welcome to this third tech launch in the three-part series about FINN.no's cloud migration. My name is Øyvind and I work in the infrastructure team at Finn. Today we will focus on what we call the cutover night, when we had some hours of downtime and moved all the traffic to FINN.no together with almost all of our services and data to Google Cloud. This is the plan for today. We'll start with a little context for you, an overview of the infrastructure for FINN.no before the migration. And then we'll talk about logistics and collaboration, a bit about how we worked during the cutover night. And then we will go through roughly how we moved FINN.no to the cloud, sort of step by step. And then we will talk a bit about how we tested to make sure it still worked afterwards. And we'll finish up by talking about the hours and days after moving the cloud and how that looked for us. So let's start with the infrastructure overview. So this is a very simplified diagram of our infrastructure as it looked sort of before we started the migration. It only includes the parts that are kind of relevant for the rest of the presentation, so many parts are kind of left out. But in any case, at Finn we have around 800 microservices, and we have had a custom Kubernetes cluster that we set up ourselves, which had big physical machines as the nodes. And in the cluster we ran around 2,300 Kubernetes pods, but this number varies a lot because most of our services auto-scale with traffic. So 97% of our services run in Kubernetes, and the remaining ones typically run in virtual machines or physical machines. And we have around 180 virtual machines. Some of them run these remaining services, but most of them are Postgres clusters or typically kind of supporting infrastructure. So we have around 145 databases that are spread across our 27 Postgres clusters and a Sybase cluster that we have. We have 3 HA proxy load balancer clusters that we use to handle all of our traffic. We use varnish caches for some of our high traffic API reads. We use Solar for searches, and we collect metrics from essentially everything into Prometheus, and we use Grafana for dashboards. We aggregate logs also for mostly everything into Elasticsearch via FluentD, and we make them searchable via Kibana. Okay, next up is Rodolfo, who will talk a bit about how we worked during the migration night.
Thank you, Øyvind. So yes, I will tell you a bit on how we worked during the cutover night. My name is Rodolfo. I'm one of the architects at Finn, and this is the story on how we worked and to be able to migrate to Google Cloud. So we were in a situation where everyone was working remotely, and this meant that we had to set up a distributed task force. A few of the engineers were located at the office, but most of us worked from our home offices. And this was all new to us, and we had to plan this in great detail. We had one common runbook for the migration night with checklists and test plans, and I'll talk more on this a bit later. But we also had a backup plans. So, for example, what if Slack or Google Meet suddenly was made unavailable, or one of the key personnel lost their internet connection in the middle of the night? So we prepared some alternative services for Google Meet and Slack, and for the no internet connection scenario, we also planned to just jump into a taxi and head down to the office. So how did we coordinate this process? So the whole process was inspired by our internal incident management framework. So in short, the whole migration was handled as an incident. We had clear defined roles and responsibilities, and we knew at any given time who was doing what, and this was really, really important. So we had a migration manager that was responsible for taking the big decisions during the night. Another key role was the incident commander. This person was in charge of the migration process, following up the checklist from our runbook, issues that may occur, and he also was responsible for communicating each step of the process to the rest of the organization. And from the infrastructure team, we also had multiple operation leads. Their responsibility was to lead and execute on the different steps of the migration. And for communication, a Slack channel was created. So this was the main channel for communicating with the rest of the organization. And we kept track of the process in a live document with all the details in a timeline. We also had some team-based VC links for more face-to-face in quote communication. And for any issues that occurred during the migration night, we established separate incident channels. So this kept us from polluting the main channel, but also to keep focus on a single topic or on the ongoing issue that we had. So we even had a Slack channel for the not so serious topics, where we could post GIFs, links to music playlists, or just show our excitement and allow for a non so strict way of communicating with the rest of the tech organization. And as you can see here, people were really excited to start the migration. And we were really excited every time our incident commander was writing a new update in our Slack channel, as you can see here. So how did we track this process? So we had two runbooks. So we had one big high-level run covering the days before, during, and after migration. So this had a checklist for everything that needed to be ready before the migration night, with team plans, shift plans, and a final go, no-go decision. And then we had the second runbook that was covering the actual migration night or the cutover night. And this was managed by our infrastructure team and owned by the incident commander. So this runbook had every single step documented in great detail. It had links to all the other important documents, metrics, and dashboards managed by our engineering teams. And the main steps of the runbook was communicated in the Slack channel as they occurred. And one very important thing, so the runbook was also made available for everyone participating in the migration. So this kept the process open and available for everybody. We also had a separate document for the cutover timeline. So this had the best case and worst case scenarios with multiple checkpoints during the night. And this was continuously updated with the actual time spent to keep track of the progress. So we talked about our runbook and the timeline, but what if we had to roll back? So did we have a rollback plan? So yes, we did. So we had a plan, but the plan was always to keep rolling forward. So the main goal was to have Finn up and running in the morning without losing any data. How was highly dependent on the outcome of the cutover night. So some services running in the cloud and some services rolled back to Oslo was fine, as long as Finn worked with minor issues in the morning. And to be able to do this, we needed to have full control of our platform, giving us the flexibility to work fast and make important decisions during the cutover night. So at this point, it was midnight, and now Øyvind will tell you about the migration process.
Okay, let's talk about how we actually moved Finn to the cloud in some technical terms. So here is roughly how it looked just before the cut overnight. There's lots of stuff going on here, but let me try to explain a bit. On the left-hand side, we have our Oslo data center. And on the right-hand side is what we'd set up in Google Cloud beforehand. In the middle is our Cloud Interconnect, which is a dedicated connection between our data center and Google Cloud. As preparation, we had, in short, duplicated many systems such as load balancers and Kubernetes, which we had set up as a GKE cluster. That's Google's managed Kubernetes system. We had replicated our databases to Google Cloud instances, and we had stretched our Kafka cluster to span across our Oslo data center and Google Cloud. The primary nodes for Kafka and for the databases were still in the Oslo data center. Also, some teams have been able to migrate some, and in some cases, all of their applications before the migration night. Some of these were running in virtual machines, but most of them were running in the GKE cluster. So if you want to learn more about the preparation, you should check out the previous tech runs in this series. So this is basically what we had to work with on the evening of September 15, which was the evening of the cutover night. So after we gathered late in the evening, we checked and we double-checked our pre-flight checklist. And then at midnight, the first thing we did was to send all traffic to FINN.no into the load balancers that we had set up in Google Cloud. Beforehand, we had configured our edge load balancer there with an allow list that would only let traffic from our internal network and VPNs through to the site. And all other traffic from the internet would be handled by showing a page saying that Finn is down tonight because we are moving it to the cloud. It looked like this. So beforehand, we had collected a list of all the DNS records that point to our load balancer clusters, besides the obvious one, www.finn.no. So to change where the traffic went, we essentially just changed them to point to the cloud load balancer clusters using our normal Atlantis and Terraform tooling. Then we waited for some minutes for the DNS changes to propagate, all while closely monitoring the request rates in our on-premise and our cloud load balancers. About 20 minutes later, we were satisfied that next to no traffic was flowing into our on-prem data center anymore, and that applications that were doing delayed processing or batch processing were done with their work or stopped. Also, because there were changes going into production kind of only minutes before we started the cutover night, it was only at this point that we could actually create the full list of applications that we would migrate during the night, and also be sure that we got everything with. This was simple enough. We could just list the applications that were running in the on-premise Kubernetes cluster and save them for later. So to avoid any kind of data corruption or other issues caused by applications running both in our Oslo data center and in the cloud at the same time, the next step in our plan was to shut down all the applications. So we did this by triggering kind of an undeploy via FIAS, which is our Kubernetes abstraction layer. In practice, this is essentially the same as deleting all the Kubernetes resources for each application, and in that way have them stop. This is simple enough, but after we triggered the deletes, it actually took a bit of time for the Kubernetes cluster to reconcile and actually stop everything. We think maybe this was due to the sheer amount of Kubernetes resources, because we saw that the etcd cluster backing our on-premise Kubernetes cluster got a significant amount of resource pressure, maybe due to the syncing between the etcd nodes. In any case, around 20 minutes later, it was all done. All the applications were stopped, and we could check and double check again that we had no applications running in the Kubernetes cluster in our Oslo data center. So when everything was stopped, it was time to switch the database primaries and the Kafka broker primaries. At this point, the work split into 3 parallel tracks, where our Kafka group worked on Kafka, our Postgres experts handled the Postgres databases, and our Sybase experts promoted a new Sybase primary. We also had some scripts run to sort of pre-warm the Sybase primary, which would bring frequently accessed data into cache memory on the new machine. None of these work streams kind of depended on each other, but all of them had to be completed before we can continue and do anything else. So we had what we called a sync point, where the different groups reported back and gave the all clear to continue. At this point, it was around 2 o'clock in the morning, and we were ready to start deploying all applications in our GKE cluster. As part of the preparation, we had created a short list of what we called vital applications. These were just over 10 of them in total. These were applications that many other applications depended on, such as Unleash, which is our feature toggling service, and the server component of our service discovery system, and various other applications that do things like provide login or user profiles. When we had deployed those and we saw that they were running successfully, we could trigger deployment of all the remaining applications. All of these were deployed using our normal tooling, which means our continuous delivery pipeline tool, which is just called pipeline, and our Kubernetes abstraction layer called FIAS. So roughly the way it works is the pipeline knows which version of each application should run in which environment. So the process was roughly for each of the applications, we tell pipeline that it should also run in the GKE cluster, and then trigger a deploy for each of the applications. And then FIAS would handle the rest, basically creating the necessary Kubernetes resources for the application to start up. And then it was a matter of letting the Kubernetes reconcile loops spin up everything. To speed up this process, we had scaled the GKE cluster up to well over the capacity of our on-premise Kubernetes cluster, so that we wouldn't have to wait for the cluster autoscaler. And we had also sort of pre-warmed Kubernetes nodes in GKE by pulling in Docker images that we were already running in production on-premise to try to avoid having to wait for image pulls. One thing which is nice about how Kubernetes works is that when an application crashes, it's just restarted automatically. So besides deploying the list of vital applications first, we didn't really care about the order we deployed things in. We just deployed everything and let applications crash if they were depending on something that wasn't available yet. And this resolved itself relatively quickly. So around 11 minutes later, we had 1,500 pods running. And only a few of them were still crashing or failing to start for various reasons. We actually had one issue where some of the Docker images that were running in production in our on-premise cluster weren't actually available in our Docker registry anymore. So to fix this, we had to trigger new CI builds for a few applications, and then they could come up as well. And then we were eventually ready for everyone to start testing that the site as a whole still worked. And Rodolfo will now tell you a bit more about how we did that.
Thank you, Evan. So how did we test the site to check that everything was working as expected? So with the green light from our incident commander, the engineering team started to go through their test plans. And each team had their own detailed test plan covering their part of the Finn platform. And when a team was done testing the services they were responsible for, the state was reported back to the main test plan, hopefully with like an OK to proceed state. But wait, during the test phase, one of the teams reported back with not OK. So they found an issue where one of the core services used in the add insertion flow was failing. So the application was throwing a lot of errors. It looked like we had an issue with the database. And anything related to data is critical. So what if the data was out of sync, or if we had corrupted data across our data centers? So we started to investigate the issue. We created an incident channel and jumped into a VC call with the team and one of the database experts. And we even had to wake up one of the tech leads for investigating this issue. So after some time and some intense debugging, we found out that the artifact deployed to Google Cloud was not the same as our on-prem data center. So we had an old version of the application running in Google Cloud, trying to connect to a database with a newer version of the database schema. And by simply triggering a new CI build in our deployment pipeline, the problem was fixed and we could continue testing the site. But so why did this actually happen? So before the cut overnight, the application was deployed to Google Cloud for testing purposes, and later it was manually stopped and scaled down. Then a change was done to the application with changes to the database schema, and this change was applied to a Postgres cluster. And since we had a database replica in Google Cloud, the change was also applied to both our on-prem master node and the Google Cloud replica. And since the application was manually stopped, the build of the application was only deployed to our on-prem data center in Oslo and not to Google Cloud. So we had an old version of the application, but a new version of the database schema in place. So at this point, we were ready to open up the gates. Everyone was finished with their testing phase, and everything was green. And Øyvind will tell you about how this was done for opening up the traffic.
Yes, so eventually all the test plans had passed, and some final checks were made, and at 4:43 in the morning, we got to go ahead to open FINN.no to the internet again. This was slightly behind our best case time estimate, but it was well ahead of the worst case. This was good because it's safer to let the system with cold caches and all autoscalers scale down start with kind of a limited amount of traffic and have it organically increase rather than sending a lot of traffic into it all at once. And also being ready this early meant that we could kind of afford to have slightly higher error rates while at the same time not affect too many users in practice as compared to if it was later in the day. So technically, we just removed the load balancer configuration that blocked external traffic from FINN.no. It was just a simple access control change. And then we, after we made that change, we kept an eye on our monitoring dashboards and braced ourselves for the real test, which is live production traffic. So even if it was in the very early morning Norway time, real user traffic was coming in fairly quickly. And that also meant that some more issues showed up. So the internal testing uncovered some issues, but with the system at the scale and complexity of FINN.no, it's extremely difficult to test everything. However, we were prepared for this, and we got to work handling all the issues systematically. Any issues that showed up were announced in our main Slack channel and were collected in a spreadsheet. where they were triaged by severity, and the teams that owned the affected systems started troubleshooting them. And the infrastructure team went through each issue as it appeared to try to understand if the root cause could be some kind of infrastructure issue, like a firewall or some kind of supporting system that should be running but wasn't. So after working on this for an hour or two, we hadn't completely fixed everything, but we had gotten to a state where the issues that remained weren't causing so much trouble that we had to have kind of a all hands on deck approach to fixing them anymore. So it was still quite early in the morning, and we had FINN.no running in the cloud with what could be considered only minor issues remaining. We can only call that a success. So we could relax a little bit and get ready to handle any issues that might show up in the days to come. So let's move on to that now. So the days after moving Finn to the cloud were actually quite, and maybe actually surprisingly calm. There were some issues that showed up, of course. I'm going to talk about a few of them just to give you an idea of what we had to deal with. So we had one issue with an application that sent emails via a third-party provider, where a missed configuration turned out that the client that called the third party didn't reuse TCP connections between requests. And when running in Google Cloud, the latency characteristics were different, which caused sending of emails to go a lot slower. When that issue was found and the application was configured to properly reuse connections, the execution times were back to normal. And we also saw a significant reduction in cloud net entries, which is good because this is a limited resource too. We had a kind of similar issue in our alerting stack, which was still running in our Oslo data center. The latency between the data center and Google Cloud made processing of keep alive messages go slowly. This is basically messages from all the various machines that are being monitored, going into the alerting system, and then saying that, yeah, the machine is still available and working correctly. So the processing of these messages was so slow that the messages kept piling up in the queue they were consumed from faster than they could be handled. And we mitigated this by temporarily moving the load balancing for that endpoint back into the Oslo data center, and then we eventually sort of solved it by moving the entire alerting stack to Google Cloud as we shut down everything in our Oslo data center. There was some other kind of more minor things that we noticed were different. So in Google Compute Engine, instances will sometimes be live migrated. For example, when maintenance happens on their systems. And this also includes the GKE Kubernetes nodes. So depending on the type of migration, the machines can sometimes be unresponsive from the outside for a few seconds before they come back. This isn't really a big issue, but it was something that we weren't used to from our on-premise data center. And in our systems, it would typically show up maybe as some alerts firing or a dashboard suddenly not having any metrics, which can seem worrisome at first, but then it turns out to be a more or less a non-issue in reality. Also, for some applications that were running in GKE, we saw more CPU throttling as compared to in our on-premise Kubernetes cluster. We think this is because the applications had very tightly tuned CPU resource requests configured, and because of the different underlying hardware and the fact that there was no virtualization layer in between in our on-premise Kubernetes cluster, the result was just slightly different in GKE. So this was solved by just increasing the requested resources for each of these applications. So there were certainly some issues, but all in all, Finn has worked pretty well since the migration. So the uptime numbers agree. Our uptime in October and in November is actually higher than the months before the migration. Next up, let's talk about some of the things that we learned during this process. So the first thing is that having cloud migration as the #1 priority organization-wide was crucial to ensuring that the cloud cutover was a success. This is because it made it very easy for everyone to pull together and do everything they could to help. We also had this very detailed runbook with essentially command-by-command instructions of what had to be done during the cutover. Each step had links to dashboards and logs where we could monitor the result of the step. And we also had the best and worst case time estimates for each step, so that we could easily see if we were on track to have FINN.no running again in the morning, or if the schedule was slipping and we would have to change our plan. So this made collaboration a lot easier and also helped to reduce the risk. Next, we ran a kind of test migration by moving our development environment to Google Cloud. So the goal of this was not to move the development environment. It was to streamline the process that we wanted to use for moving production. So we did this using the same process that we were planning to use for production. We had the runbook, we had the incident commander, we had operational leads and the live document. And this process helped us make informed time estimates for moving production. And it also helped us learn a lot about what worked and about areas where we needed more preparation. It was a very valuable part of the preparation process, and it also gave us the confidence that we could, in fact, pull this off. Finally, we were able to move many things before the cutover night. Some teams were able to migrate parts of their applications, and some teams were able to move actually all of their applications before the migration night. This helped us uncover many issues that we could then fix before the cutover night. And this could have been issues that we would otherwise have to troubleshoot at 5 o'clock in the morning during that night. So it's nice to be able to avoid that. Okay, that's all we had to share. We will answer your questions after a short break.
Siste punkt på agendaen printeren. Printeren altså ganske kostbar når vi hele tiden må bytte blekk. Kopimaskinen begynner å slite fordi noen har satt seg på den. FINN.no.
So thank you for presenting, and now we are ready for questions and answers. My name is Henning, and I'm one of the architects at Finn, and also lead all the Kafka migration workstream. And in addition to the presenters, we also have Arian and Nina, who did the Postgres migration. And we already had some questions, and you see on the screen the code you can use on Slido to ask more questions. The first one: how tightly are the incident management and the cloud teams coupled in normal working scenarios?
Yes.
Will you start with that, Jon Øyvind?
Yeah, I think I can answer that. I was the incident commander for Finn when we did this cutover. I think to start with, I guess we're one big cloud team in Finn now. We don't have any on-premise data center anymore. So But in general, we try to handle all our production issues and larger operations like this as an incident, and we have been doing that for some years. The way we do it is, like Rodolfo briefly mentioned earlier in the presentation, we do it like a lot of other large and smaller tech companies do. And if you've seen the Google SRE book and how incident management is described there, it's going to look pretty familiar. If anything goes wrong during a normal working day, we would follow basically the same procedure as we did during the cutover night. We will have someone take up the role as an incident commander. That will normally be whoever discovers an issue. We will set up a separate channel for it. We will make a live document, make sure we have operational leads working on the technical aspects. And depending on the size of the incident, we might also bring in people to deal with communications, for example, with media. If it makes sense, we'll set up a post-mortem as well to kind of try and understand why we had an incident and see if it's possible for us to prevent it from happening again. So all in all, I'd say that the fact that we handle this as an incident and that we're used to handling incidents in this way, I think it made it a lot easier for us to actually execute the migration. I hope that answers the question.
I also like to add that for me, the getting a little bit process around incident handling improved our situation a lot. It was much more arms and hands and people running around before we had this process. And one of the authors of that chapter in the SRE book have actually worked with Finn, so it might not be a coincidence that we follow the same principles. Thank you, Jon Øyvind.
Thank you.
How bad would the migration have to go for you to actually start rolling back to the data center? And would you be able to keep the state of the services? Arian, are you the one to start on this one?
Yeah, at least I can give it a try. Yeah, I had the same concern. We had a lot of discussions. It was hard to make a decision beforehand or define the criteria. We had one clear red line, and that was data loss or data corruption. If that happens, or if there's a fear of that, we won't proceed, and we will do a rollback. And we also had a yellowish line when X% of services, Finn services, were failing. X at the time was a concrete number. We are not going to talk about that because that's not relevant. The relevant point here is that we had experts for different systems and subsystems, and we trusted them that they will come with a good recommendation if we needed to make such a decision. Yeah, and the second question, would you be able to keep the state? Yes, because the first criteria was to avoid data corruption. It depends what's meant by a state here. Some of the states are not persisted, then yeah, they could have been lost. Others that are persisted, no, we didn't have problem with that. It's a 1 hour topic. It was dependent on when we decided to do a rollback, whether we have received user traffic or not, and how much user traffic. That's my take on it.
I could add that for different storage systems, we have different strategy or plan. So for Kafka, the design was that we could flip the leaders to any data center. So a rollback there shouldn't really be a rollback. It was just a migration of where do we have the leader of the data. Whereas for the databases, I think it would be a little bit more work.
For the databases, we set up replicas. We kind of did a round-trip replication. So we replicated from the old data center to GCP, and then we also replicated back. So we had a replica, or we had a node in each cluster that replicated from GCP that we could just switch back to if we needed to roll back. Then we wouldn't have lost the data.
So quite similar. Yeah, so quite similar to the Kafka situation, actually. Yeah. We had all the data in both data centers. And then we had a legacy database, which would be a little bit more work probably then. Yeah. But we won't go into those details. So we take the next questions. Did anything not go as planned during the migration? Can anyone remember anything that didn't go as planned?
I mean, there were many things that didn't go as planned, or there were a whole bunch of issues that showed up during. But it was just a matter of figuring out each one and solving them as quickly as possible with the goal of bringing Finn up again in the morning.
Yeah, I don't think we didn't have to kind of change the plan itself. I think the steps in the plan were kind of followed and worked as expected. And as you said, a few issues turned up, but they were dealt with there and then.
Same from a Kafka point of view. The major steps in the plan worked fine. There were some small issues, but we had sufficient time and control to just fix those. And in a way, that was a part of the plan. We planned to fix the smaller issues that we knew would show up. But the problem is that if you don't have that kind of control on the bigger picture, when things start to not go as planned, everything could become a disaster, is my experience from other incidents and other migrations or big events. Let's take the next. How did your applications handle the difference between running on-prem and in the cloud? Did any application need changes when being deployed to the cloud?
So we can talk about the last part of the question. So did any application need changes? So the answer is yes. So we did an assessment of all the applications that we had on-prem, and then we did a lot of changes and tweaks to be able to run them in the cloud. And some of the applications just needed to be assessed. And then we had a lot of other applications that also needed to know where they were running, so in the cloud or in our on-prem data center. So we did some changes, and this was also tested ahead. So we verified that the changes also worked before the migration of the cut overnight. And then the first part, so how did the application handle the difference? Maybe somebody from the infrastructure team can say something about that. Arian?
I think they handled it well. There were problems, as Oyvind mentioned in his presentation, that one vCPU is not one vCPU on-prem and off-prem. We accounted for hyperthreading. So we had hyperthreading enabled already on-prem, but still some applications needed to have an update on their resources, because it's a multi-tenant environment and we don't know what's going on under the hood. But all in all, they handled it well, and we needed to update a few things. Oyvind?
Yeah, I think the fact that we run almost everything in Kubernetes is it kind of helped us with this, because we run on-premise, Kubernetes on-premise, and we run Kubernetes in the cloud, and the way we deploy things is the same. So from that perspective, the differences aren't really that big. It would more be things like network-related things, changes in latency, because the application is running in a different physical location. That would be causing issues. And we saw some of that, as I talked about earlier.
Yeah, so we had a lot of applications, well, not a lot, but we had some few applications where we had to do some network changes and prepare them for the new location, but that was also done ahead and verified as well, so yeah. What about the Kafka services?
Yeah, so there we had to do, since we were going to stretch the cluster, when the cluster was set up in the stretch mode, we changed the bootstrap list, so the list of the servers you could contact, and changed them into the servers that were in the new data center. Fortunately, for all the applications running in Kubernetes, that was basically an environment variable that the application could pick up. So, but we used to have more variation in hard-coded lists and different ways of picking that up. So that was one of the tasks this autumn, was to fix how do you connect to Kafka. Use the environment variable, and you don't have to think more about it. I also think we mentioned the cloud assessment sheet in the previous talk, didn't we? But a short recap was that all artifacts were listed in a big spreadsheet with some criteria on that you have control on CPU use, you don't log too much, those kind of things, which was helpful to get some overview and fix the worst offenders, so to say. I also think we had a handful of applications that did some checks on which environment they were running in, but I don't remember why. It might be that they just wanted an illusion of more control. Do you remember, Rodolfo?
I think some of the applications were migrated before the cutover night, so that they needed to know which location so if they had other dependent services and they wanted to take the shortest route and talk to the local service, they need to know where they were running. So I think it was that was one of the reasons.
Yeah.
And this
Makes
was
sense.
sort of changed after the cutover, where they went back to the old configuration.
Yeah, we also set up Kafka rack property, so that in theory an application could contact the local Kafka cluster to get a replica. If we ended up in a situation where we had to run some workloads or several workloads in both data centers at the same time. In the end, we didn't use that feature so much because it was very successful. Yeah, next question then. What kind of services did you postpone migrating? I can take one. In Kafka, there is a zookeeper component, which we found that we could migrate later. So we did that a few weeks ago only.
Thank you. I think the rule of thumb there was that if a consumer of a service can tolerate the extra latency, and that's not an important service, we don't migrate it, just to save us time.
Yeah, so this was also very, we talked about this in the previous tech lunch. So we had one of the legacy services where we investigated, did some preparations, and then the conclusion was that we were not going to move that as part of the cutover night. And we did that a couple of weeks later, I think. And this was a legacy service that tolerated the latency, and then we just left it there, and then we did the migration. We had better time to do the actual migration of that single service.
Sorry, Ivan.
I was just going to say that many of the things that we didn't move during the cutover night were typically supporting systems that are maybe not in the critical path for serving user requests, kind of behind the scenes tooling and so
on. And asynchronous that just worked off a queue and didn't, were in the part of the critical path. That's a very good point.
Yeah.
So the next question then, what was the biggest surprise? I have one, but any favorites, other favorites?
My favorite is the lack of any major incidents after we actually migrated. Because I was expecting more issues than we've seen.
I agree.
Yeah, and I also think that everything went smoothly during the night was also a big surprise. I was also expecting much more action.
That was mine as well. Everyone was celebrating when we added traffic at 5 o'clock, and email from CEO in the morning, congratulations. But I knew from the old days when we released during the night, you get the first peak around lunch, and then you get the second peak after Dagsrevyen and around 9 o'clock in the evening. And regardless of how well the morning went, you could still get into big trouble in the evening. So I didn't celebrate until midnight, so the next midnight. But nothing happened. I even tried to take down a Kafka broker to see what happened, and it just worked. So to me, that was the biggest surprise. I was really confident that we would manage it, but I did expect something to blow up. Next question.
One interesting thing, since we all talked about positive stuff, I try to be that person. One positive observation, it was kind of surprising, was that we saw a performance issue on some of our databases a few days after the migration. And that was really strange because we didn't make any change. They had enough resources. When we investigated more, we saw that the cache was purged, or the buffer in the memory was purged frequently, and something was consuming that huge amount of memory. And then we realized that it's virtual I/O balloon. That's a service, that's a part in the Linux kernel, but it's a service used by GCP to provide you with a recommendation. If you have allocated too much memory, it will tell you that, okay, you don't really need that much memory. Shrink the VM. And that was causing cache purge and performance decrease, which was an interesting thing, and we fixed it in, I think, half an hour or so.
So that's the learning. There's more magic in the Google Cloud than in our old on-prem Iron, direct on Iron boxes. And also, you mentioned the vCPUs, and you can get Sandy Bridge cores if you get the oldest in Google, and those are quite a lot slower than what we used to have in on-prem. So an increase in CPU usage if you use the N1 instance type is actually not a surprise when you know our underlying architecture. So when are we finished cleaning up the on-prem DC?
About a week ago, I think. To be honest, we don't have any presence there anymore now, so we're not cleaning up anything more. The people who manage the actual data center still have some machines left to turn off and move away, but we're done.
Fantastic. It's often that you do the big migration, but there are still some things lacking. So great work. Next question. Does Finn practice Google SRE principles and practices actively? I think that must be a question for a team lead. What do you think, Jon Øyvind?
I'd say that we probably don't follow all of them, and we have some active work to do, especially on, I think, SLAs and SLOs. But we do try and follow those principles, and we have basically been doing that for years. But we're not kind of following the Google SRE book and doing all the calculations and stuff, at least not yet. But it's absolutely the way we are going.
And then the next question, what would have been the consequences if you had failed? I guess that depends on the definition of fail, but it's a really worst case would be that Finn wouldn't get up. That's pretty bad because that's where we earn money. So
I also think it would have been a huge disappointment for us as both as a team and a company if we kind of failed to pull it off. But that didn't happen, so I'm not going to spend a lot of time thinking about it.
I think it's a bit difficult to answer because basically because of how do you define failed. Usually when we run into trouble, it's not like the entire site is down. It's usually kind of a part of it that doesn't work correctly, and then we work to fix it.
Yeah. Let's continue with the last question, and we're just exactly on time. And this is a favorite. Why using Postgres replicas and not migrating to managed Postgres in GCP?
Yes, we covered this in the last tech lunch too. So you can always go back and take a look at that. But this was definitely something we thought a lot about, how to migrate out of the running Postgres on VMs. There were two big reasons: that we didn't have a lot of time, and also that to migrate into managed Postgres in GCP, we would have to dump it or export and import all of our databases into GCP, which would require a whole lot of downtime, and which we just couldn't do, really. We weren't allowed to have that much downtime that it would take. And also we tried setting up Postgres in GCP, but we ran into some configuration issues running it or setting it up in Terraform, which we use. And had we had more time, maybe we could have fixed those issues, but with the time we had, we just decided to keep running them on VMs in GCP too. And rather go back and try to find a better solution after the migration, which is what we're going to do now.
Yeah, so we might not be running it ourselves in the future, but that decision is not yet taken, probably.
I do want to say that most likely someplace in the future we won't be running it at least not the way we do now. So it is something we aim to move away from.
Great, thank you. That was the last question. So do anyone want to add a final remark or message to anyone trying to do the same?
So I think the important thing here is to actually plan everything in details. And then the part where we did a lot of testing and actually tested it in production with some live applications was also very important, because a lot of the issues we found then was fixed. And if they would have come up during the cutover night, I think we would be in much bigger trouble, because we had a lot of unknowns that we could fix before the big migration night. So planning is key. And also having it as one common goal from the management. So this was the biggest goal and the most important thing that we did at Finn for 6 to 8 weeks, and that was also a key for the success, I think.
There's some British slang saying proper planning prevents poor performance, and I think that applied here. And avoiding conflicting goals, that always helps. So thank you for attending the panel, and thank to you for listening to us. This was the final and the third part of our tech lunch on our cloud migration. Follow us on Twitter or ask questions there if you have something to follow up. And we all wish you a Merry Christmas and God Jul. And finally, don't forget our furry friends during the holiday season. Thank you.
Dette blir Pinda og Pintores aller første jul.
Han får julegave han også, på lik linje som ungene.
For de får jo gaver, de får jo lov til å pakke opp. Det blir opp til et par tusen kroner også, for å si det sånn.
Skal vi pakke opp en gave? Se den store gaven her, da. Ja, nå må du se her.
Skal dere få julegave? Hva er det for noe? Oi!
Amandus, kom her.
Ble jeg rocky, ja?
Pirurus?
Og du er rekost, Amandus.
Er Pirurus, Anna?
Nei, det vet jeg ikke.
Oi! Det er en varmelampe. Er du glad?
Her kommer julegaven.
Wow! Nå tror jeg pinnedyrene blir glade.
Anton, se! Så kan du bære varene dine selv, Anton.
Se på den, da. Den er mye finere. Nei.
Jo, på største her. Vi prøver her igjen. Kom da.
Tar den maten. Kom.
Synes du han ser fornøyd ut, da?
Ja, kjempefornøyd. Helt den får seg en skinke til.
FINN.no
Kom her, skal du få rekeost.